All right, let's see how you did on this U-try here. So what we're doing is we're trying to find, we know what log base 5 of 2 is. We don't know what log base 5 of 250 is. So I'm going to break this up. This is 2 times 125. So 125, this is going to be a good number to use to evaluate log base 5 of 125, I think. So let's start writing this here. Log base 5 of 250 equals log base 5 of 2 plus log base 5 of 125. So I've just taken this 2, put it here, 125 here, and I add them together. And when I add them together, I multiply these guys. So log base 5 of 2 is 0.4307. Log base 5 of 125, I don't know what that is, but let's evaluate this log here. Log base 5 of 125 equals x. I take this x, put it right there. 5 to the x equals 125. 5 times 5 is 25. Times 5 again is 125. So x equals 3. If you weren't sure about that, you can say, okay, 125, and this is 5 times 25, which is 5 times 5, so 5 3 times, 5 to the third power. My bases are the same, so now I can just look at my exponents. X equals 3. So this mess equals 3. So I can come over here, I can substitute 3 for this mess, and I've got 3.4307 is my answer. Sorry, that's a messy 3. All right, let's keep moving. The next property we're going to look at is the quotient property of logs with a U. Quotient property of logs. All right, so the quotient property looks like this. Log base x of a over b equals log base x of a minus log base x of b. Now, notice something here. This b is going to end up being negative here. And the a, when I split this up, is going to end up being positive. So if it's in the numerator, it's going to be positive. If it's in the denominator, then I'm going to have minus or negative here. So that's an important way to make that distinction. So here's an example. Log base x of 5 over 6 equals log base x of 5, my numerator, minus, since my denominator is down here, log base x of 6. Okay, now in the book they give us this crazy example that we're going to do here. And here's what it looks like. The pH of some substance is log base 10 of 1 over H plus. Find H plus if the pH equals 4.2. Okay, so let's see what we can do here. So the pH is 4.2. 4.2 equals log base 10 of 1 over H plus. And so now I just need to solve for H plus here. So I'm going to split this up into two expressions. I'm going to say 4.2 equals log base 10 of 1 minus log base 10 of h plus. So I've just used the quotient property to split up the numerator and the denominator in this way. Now I'm going to evaluate this one, and then we'll go from there. So let's evaluate this. So I'm going to just kind of break off here. Log base 10 of 1 equals x. X jams in here. 10 to the x power equals 1. Now remember, any number raised to a certain power is 1. What is that certain power? 0. Any number raised to the power of 0 equals 1. Okay, so that's 0, so that just goes away. I can ignore it. So I've got 4.2 equals negative log base 10 of h plus. Now, I've got to, I'm going to multiply both sides by negative 1 in order to get this, get that negative over here. I want the negative over here, so it's going to be a little bit easier for me to do my evaluation. So think of this h plus as an x. We're just calling it h plus, but just think of it as a variable that you might normally be using. So let's get this negative out of here. So what I do to one side, I do to the other. Let's multiply both sides by negative 1. So now I have negative 4.2 equals log base 10 of h plus. So now what I need to do is I need to jam this negative 4.2 up in here. So the h plus falls out, and I end up with, I'm going to move this h plus over here to the left. H plus equals 10 to the negative 4.2. Okay. Now I can plug this into my calculator, or I can just leave it like this. I am fine to just leave it like this for your answer. All right, that is quotient property, and that is the only example that we're going to do of the quotient property. Now we are going to do the power property. Power property of logs. And the way the power property works is I start with log base x of a to the b power. And what I do here is I take, if I have this number raised to a power, I can take this power and plop it down into the front. So it looks like this. I take that b, smash it down over to the front, and I end up with b log base x of a. And that's all the power property is. So let's look at an example. What does that look like with numbers? Log base 2 of 6 to the 5th power equals, this 5 I can move down to the front, 5 times log base 2 of 6. So let's do an example like one of the ones we did earlier. Use log base 2 of 5 is approximately 2.3219 to approximate log base 2 of 25. So now remember 25 is 5 times 5, which is 5 squared. Okay, that's going to be helpful here in just a second. So log base 2 of 25 equals log base 2 of 5 squared. I'm just rewriting 25 as 5 squared. And so now I can take this power up here and bring it down over here to log base 2 of 5. Now I know what log base 2 of 5 is. It's 2.3219. That's what this is here. And so now I just say 2 times that, so I can plug that into my calculator, whatever, and I end up with 2 times 2.3129 is 4.6438. And it will be approximate because that's approximate up there. And that's all there is to it on that power property. Now I'd like to do an example of how to, if we have a variable and we want to solve for that variable. So let's go ahead and do that. Here comes an example we're going to solve using the properties that we know now. I've got log base 6 of x plus log base 6 of x minus 9 equals 2. I'm going to solve for x. So I'm going to use my product property. Notice I have the same bases here. And so I can multiply these two expressions. I can multiply x times x minus 9. So I'm going to do that. I'm going to say x, let's rewrite it as log base 6 of x times x minus 9 equals 2. I'm going to ignore the 2 for right now. I'm just going to keep that going. Now this x gets multiplied in here, so I have log base 6 of x squared minus 9x. So I'm going to put that in parentheses here. Equals 2, so that minus 9x is part of this log here. It's not somewhere else. So now, here's what I'm going to do. This looks like I'm pretty stuck, but I am going to take this 2, jam it in here, and I'm going to rewrite this as a power. So x squared equals, 6 squared equals x squared minus 9x. So I'm taking this from a logarithmic expression and rewriting it as, oh man, my words have gone. I'm rewriting my log as a different kind of expression here. If you put it in the comments, if you can remember what I'm trying to say. 6 times 6 is 36 equals x squared minus 9x. Now I'm going to subtract 36 from both sides. And I'm going to get 0 equals x squared minus 9x minus 36. And then I'm going to factor this. And I have to think, what do I multiply together to get negative 36, add together to get negative 9? And let's see, 12 and 3. So I'm going to say x minus 12 times x plus 3 equals 0. So now I solve each of these binomials for 0 and find out what x is. So for this one, x is 12, positive 12. 12 minus 12 is 0. And for this one, x is negative 3. Negative 3 plus 3 equals 0. So what I'm going to do here now is I need to take both of these, plug them back into my original equation, and see if either of these are extraneous solutions and therefore are not going to work here. So if I plug 12 in here, 12 minus 9 is 3, 12 is fine here. So these are fine. They're not 0 and they're not negative, so those are fine. If I plug negative 3 in here, that's negative. Negative 3 minus 9, that's negative. So negative 3 does not work as a solution. So only x equals 12 is a solution for this equation. Let's do another one. Let's do this. 2 log base 7 of x equals log base 7 of 27 plus log base 7 of 3. Cool. So I want to solve for x. So now I've got 7, 7, okay, all my bases are 7. And I've got, let's make sure I wrote this right. Okay, so what I want to do here, I need a plan. And I think I want to combine these two, and then I'm going to look at it again. So let's just leave on the left by itself. Log base 7 of x equals log base 7 of 27 plus log base 7 of 3. I'm going to multiply these two in order to combine them. Log base 7, 27 times 3 is 81. Okay. Now, I think I feel like I'm getting closer now, like I can do something. I'm going to take this 2 and put it up here as x squared. Log base 7 of x squared equals log base 7 of 81. So I used my my power property to move that was in the front up here as squared. Now look, I've got log base 7 of x squared, log base 7 of 81. I can ignore these log base 7s here and just look at x squared equals 81 now. Now I've got x squared equals 81. I'm going to take the square root of both sides. X equals 9. And that's it. That's my answer. Let's have you guys do one, and this will be the last example, I think. Maybe. Probably. Yeah, let's do this. Log base 6 of x plus log base 6 of x plus 5 equals 2. So this one looks a lot like that first one we did, and you're going to solve it in a very similar way than the way that we solved that first one. So go ahead and get to work on that, and we'll come back together and see how you did. Go ahead and pause and get to work. All right, let's see how you did. Okay, so I'm going to multiply these two and combine these logs. So log base 6 of x squared, x times 5 is 5x, equals 2. I'm going to take this 2, jam it up in there, and change this to a different kind of expression. X 6 squared equals x squared plus 5x. And now I'm going to, this is, x squared is 36. I'm going to subtract 36 from both sides. 0 equals x squared plus 5x minus 36. What do I multiply together to get negative 36? Add together to get 5. Let's see, x plus 9, x minus 4. That'll get me positive 5, and that'll get me negative 36. Great. So now, set each of these equal to 0, x equals negative 9, x equals positive 4. If I plug negative 9 up in here, then I've got a negative here, I'll have a negative here. That one doesn't work. If I plug in 4, 4 that's positive, that's fine. 4 that's positive, that's fine. So x equals 4 is my only solution. And that is 7-5. Good luck on the homework.